What if you could describe something as personal as human conviction with the same kind of precision that physicists use to describe gravity? Well, today we're diving into a pretty radical new idea called cognitive physics. It's an attempt to do exactly that by borrowing the language of field theory to map our very own minds. Okay, so just think about it for a second. Your entire landscape of beliefs, your identity, your strongest convictions, everything. What if we could actually chart all of that with the same mathematical rigor a physicist uses to map, say, a magnetic field? That, in a nutshell, is the wild premise we're exploring today. All right, so here's our game plan. First, we're going to learn the basic language of this new physics. Then, we'll use it to build a model of a single mind. From there, we'll look at how that mind can change, zoom out to see how lots of minds interact, and then finally, we'll get into why any of this actually matters. So, let's just dive right in with the most fundamental idea. How in the world can we possibly translate the messy, complicated internal world of our thoughts into the clean, crisp language of physics? Well, it all kicks off with something called the cognitive field. The easiest way to wrap your head around this is to picture a map. But instead of a map of a country, it's a map of ideas. Maybe liberal is on one side and conservative is on the other. At any given point on this conceptual map, the field has a value. You can think of it like a tiny arrow. It points toward the idea you're leaning into, and the length of that arrow shows how strongly you believe it. Okay, so now that we have this basic tool, this cognitive field, we can actually start using it to model the shape of an individual person's identity. Let's see how this framework builds a picture of one person's convictions. And to make this really concrete, let's imagine the absolute simplest belief system possible. You're either committed to belief A or you're committed to belief B. There's no middle ground. How does a theory like this even begin to model that? It borrows this brilliant concept from physics called a double well potential. Picture a landscape with two deep valleys. Your identity is like a marble. It can rest really comfortably and stably in the left valley, that's belief A, or it can rest in the right valley, that's belief B. Trying to balance that marble right on top of the hill in between, that's totally unstable. You're going to roll down into one of the wells one way or another. So the key here is that these wells represent our stable, comfortable convictions. So what do we call that boundary between belief A and belief B? The theory has a fancy name for it, an identity soliton. Now, don't get hung up on the physics term. Just think of it like the surface tension on a drop of water. It's not just some imaginary line, it's a real, stable structure that holds the belief together and separates it from all the other drops of belief out there. It's the very thing that gives our convictions their shape and their resilience. But of course, our beliefs aren't set in stone. They change. I mean, people change their minds all the time. So how does a model like this account for those sudden shifts in opinion, or even our entire identity? Well, it happens through a process the theory calls a cognitive bifurcation. Here's how it works. First, you've got a stable identity. Our marble is sitting happily in one of those wells. Then, some kind of external pressure gets applied. Maybe it's new evidence or social influence. This pressure starts to make that well more and more shallow. And when it hits a critical point, the well just vanishes entirely, and whoosh, the marble suddenly rolls over into the other valley. A belief completely flips. Now, what's so fascinating here is that this tipping point isn't just some vague metaphor. In this model, it's a precise, quantifiable value, represented by SC. It's the exact amount of external pressure needed to make a stable belief collapse. The theory even makes a prediction you can test. As you get closer and closer to that tipping point, your decision-making should get slower and more hesitant. It's a phenomenon called critical slowing down, almost as if your mind is fighting to stay in that well as it gets shallower and shallower. But, our minds are not perfect deterministic machines. They're noisy. There's all this randomness from neural fluctuations. You get distracted, you make sampling errors. The theory models all of this as a kind of cognitive temperature. And this cognitive noise has some pretty profound effects. First, it can randomly kick your identity over that hill into a new belief, even without any strong outside pressure. Physicists call this Cramer's escape, but you can just think of it as a sudden, spontaneous change of heart. Second, it makes those belief boundaries, the solitons, wander around randomly, like a fence line that's constantly shifting in the wind. And finally, the closer you get to a tipping point, the more this noise gets amplified, causing your conviction to fluctuate like crazy right before it finally flips. So, up until now, we've only been talking about one single mind. But the real power of this framework, where it gets really interesting, is when we start connecting multiple cognitive fields together to model an entire society. So the theory proposes three basic ways our cognitive fields can interact with each other. There's attraction, which models things like empathy and cooperation. That's where our fields kind of reinforce each other where they agree. Then there's repulsion, which models polarization and conflict. That's where the boundaries between our beliefs get really stiff and push each other apart. And finally, there's exchange, which models persuasion and learning, the direct flow of ideas from one person's field to another. And really, all these interactions, they tend to boil down to two major social outcomes. When attraction is the main force at play, you get synchronization. Our individual belief fields literally start to overlap and merge, creating a coherent group identity. But when repulsion takes over, you get conflict. Those identity boundaries we talked about, the solitones, they harden up into walls, pushing us further and further apart and driving the kind of polarization that we see all around us. Now, this leads to one of the most powerful and, I think, beautiful ideas in this entire framework: collective memory. The theory suggests that the entire history of a group's interactions doesn't just disappear. It actually gets encoded into the very shape of their shared cognitive landscape. This becomes the model for culture, for tradition, even for things like group trauma. The past literally sculpts the terrain on which all future beliefs are going to form. So we've built this thing all the way up from a single field to a whole society. But what's the ultimate payoff here? Why is this more than just a really elegant mathematical analogy? What's the point? The real goal is unification. This quote from the source material really captures the ambition here. To describe all these wildly different social and psychological things, empathy, conflicts, memory, learning, not as separate problems, but as emergent properties of one single underlying system, the interaction of our identity fields. So let's just boil this all down. The key takeaways. Cognitive physics offers a single, unified model for both individual minds and social groups. It takes these fuzzy concepts we use all the time, like tipping points and polarization, and it makes them mathematically precise. It gives us a brand new language to talk about how history shapes culture through this idea of collective memory. And maybe most importantly, this isn't just philosophy. It makes specific, falsifiable predictions that can be tested in experiments with both humans and with AI. And that leaves us with a final, pretty mind-bending question. If our thoughts and our social dynamics really do follow predictable physical laws, could we one day use a framework like this, not just to explain our present, but to actually map the likely futures of our collective beliefs?